go through the key now with you guys for this one to make sure that we understood a few of these concepts. I'm gonna skip through the first few though. You can look. You guys have this sheet. You can look through it yourself too. I'm gonna go to just start number 4, I guess here, just to make sure that you are still doing the total time, right? So we got to figure out the time for each section that we went through. So number 4 was very similar to the ones that I did on the other videos. Number 5, a little bit different. Number 5. So man walks for 25 seconds at the speed of that, and then runs for 40 seconds at the speed of 3 meters per second. Really, it's the same type of thing too. It says how far does he travel, what was his average speed. So what we had to do on this one though, it gave us velocity for each, part 1 and part 2. Gave us velocity, it gave us time. We had to figure out the distance for both those. So we figured out distance 1 was that, distance 2 was that. Then we added them together because we need total distance. That's what went on top. And then total time, we just added 25 and 40 to get 65. And then that's our average velocity. Okay, the Rhino one, so number 6. So the Rhino saw some tourists that were 700 meters away. And we wanted to know how long they had to get in the vehicle. So for that one, all we had to do was look at the 2 parts of the Rhino's journey. So the Rhino went... So part number 1 of the journey, he's going 2.5 meters per second for 500 meters. He's not going very fast. Then all of a sudden he starts going a lot faster. So we got to figure out the time for both those parts again. So just using our formula, we can figure out the time for part 1 is 200 seconds. The time for part 2 when he starts going faster, he or she, I guess, I guess it's he. So part 2, if you figure it out, is going to be 30.8 seconds. Add those 2 together to get your total time, and that's how long they have to get into the vehicle. Then you can just figure out the average velocity by taking the total distance and dividing it by your total time. Okay, the turtle hare one, number 7. So the turtle and hare are in a race. The turtle doesn't go very fast, the hare does go fast, and they both run for the same amount of time. So in that one, we start off and say, okay, so that 4.5 minutes though, we need to change that to seconds because our velocity is in meters per second, so that has to be in seconds. And then just figure out your distance for your turtle. And then do the same thing, but with a different speed for the hare. Same time though, they got the same time. And that's our new distance. And then all we gotta do is subtract those 2. That'll tell you how far apart they are. So that's that. So number 8, Jake and Mac. Number 8. Yeah, Jake the snake. Oh yeah, and this one, so Jake can slither at 125 centimeters a second. Mac, the rat, can run at 200 centimeters a second. If they start at the same point, how far apart will they be after 5 seconds if they both run in the same direction? One thing to notice here, though, is it says centimeters per second and centimeters per second. We can actually leave this one in centimeters per second if we want to. We can do everything we want to. We just need to know that the answer that we're going to get out of this will be in centimeters. But that's fine. That's the answer they give us here too. So let's go back. So for Jake, the time is the same for Mac. The velocity is the only difference, right? So we got to figure out the distance for Jake. I got that like just a lowercase j for Jake. And if you figure that out, rearrange that formula, you get 625. For Mac, just with the 200 centimeters per second, you get 1,000 centimeters. And then again, all you need to do is subtract the difference, or subtract them to find the difference, I should say. All right, for number 9, Jake the snake's tail is 345 centimeters in the hole, and he slithers under stress at 150 centimeters a second. How can Mickey the mongoose catch him before he escapes? Mickey can move at 450 centimeters per second, and he starts at 10.8 meters from the hole. So for this one, you've got the mongoose, which is going 4.5 meters per second, and you got the snake going 150 centimeters per second. We were able to just keep the time for Jake in centimeters. You could have converted this to meters and meters per second, but what's going to happen is since the distance is in centimeters and the bottom one centimeters per second, the centimeters cancel. My answer is going to be in seconds anyway, so we just left it like that. Figured out that the time for Jake the Snake was 2.3. If you go down a little bit, the time for the mongoose, just doing the same thing, was 2.4. So therefore, Jake escapes down the hole. Number 10. Jack the Jaguar can run for only 1 minute at 13 meters per second before he has to stop and rest, while Zeke the Zebra can gallop at 7.25 meters per second for 5 minutes. How long does Zeke actually have to run for to elude Jack? Can Jack catch Zeke for lunch if they are initially 350 meters apart? Okay. So for this one, Zeke the Zebra, what we need to do is figure out, for this one we got to figure out mostly, or really just how far, so if this was, I don't know, Zeke, he's going to be here. It's going to be how far does he go? Why is that so thick? It's weird. And then Jack, how far will Jack go, right? We want to figure out if one will actually escape the other. So to do that, the time for Zeke is going to be 1 minute, not 5 minutes, right? Because the question says that Zeke the Zebra can gallop, at that many meters per second for 5 minutes. I don't really care about how long he can do that for because it only matters how long the Jaguar is running for. So we're going to use that time, not the 5 minutes. So we use 1 minute, we have that velocity, we figure out a distance of 435, but he started 350 meters already away from Jack, so we just need to add those two together. So in total, that's the distance. Okay, then part 2, Jack, we just have to figure out the distance for Jack was 780 meters. So 785 is greater than 780, therefore Zeke escapes. And then the second part of the question is why wouldn't that work in the real world? In the real world, zebras are from Africa and jaguars are in South America. Okay, last question. For this one, Mr. Light is standing 50 meters from a large bell. With his mighty throwing arm, Mr. Light throws a rock at the bell, and he hears the sound of the bell 4.5 seconds later. If the speed of sound is 330 meters per second, what was the speed of the rock in the air? All right. Okay, so we have to think about this question with having two parts. There's going to be the part where we throw the rock, or Mr. Light throws the rock, so that one. And then part 2 is going to be where the sound leaves the bell and comes back to the person. So the total time here is going to be the time it takes for the rock to get to the bell, plus the time it takes for the sound to get back to us. So part number 1, we got to figure out the time that it was for the sound to get from the bell back to us. So to do that, we know the velocity of sound. So we just got to figure out the time it took for the sound to get to us. So that's just going to be 50 meters, because it's 50 meters away from us, divided by the time, or the speed of sound. And that's going to give us a time of 0.152 seconds for the sound to get back to us. Okay, the total time, like I've got up here, is going to be equal to the time it takes for the rock to go there plus the time it takes to go back. We know the total time is 4.5 seconds. That was given in the question. So now we just need to find the time for the rock. And the way we do that is just by rearranging this equation. We just subtract 0.152 from both sides. And we end up with the time it takes for the rock as 4.35 seconds. Okay, and then last step, we just go the velocity of the rock is going to be equal to the distance, it was 50 meters away, divided by the time it took for the rock to get to the bell, and that's going to be equal to 11.5 meters per second. Now questions 12 and 13 were bonus questions. Look through these and see if you can figure out how they worked. Okay, so that's it for lesson 1. I hope that everything went well for you guys. I'll see you guys in lesson 2.